All right, let's continue with part 2 of chapter 6, section 3. To proceed, we need the concept of quadrants. Yep. Okay, so what are we trying to do here? Previously, we knew what the trig function values were up for 0, 30, 45, 60, 90. Now, we are going to move on to what about 120, 135, and a few other angles like that, greater than 90 degrees. For that, we need the concept of quadrants. The Cartesian plane is divided into 4 quadrants as shown. So, if you look at this XY Cartesian plane, this quadrant is considered to be the first quadrant, and this is the second, third, and fourth. That's kind of weird, man. Yeah, but it's not really weird when you think about a certain thing. That is, let's say we have a line segment or a ray, doesn't matter, a line segment which is initially oriented at 0 degrees, which means its one end is at the origin, that is fixed, doesn't move. The other end is the one that keeps rotating. And how does it rotate? Initially, it lies right on top of the positive x-axis, so that the angle at that time is theta is equal to 0 degrees. And as theta increases, counterclockwise, it rotates counterclockwise, that line segment. And so that's where theta would be increasing, now would reach pi halves or 90 degrees, and 90, 100, 120, when it gets to this point, it's 180 and continues on. You have 270, right? I'm adding 90 each time. So 0, 0, 90, 180, 270, and back to 360, a full circle, right? So if you look at the way that segment is traversing as theta increases, no wonder we call this as the first quadrant, because this is the quadrant in which that line segment lies first and then goes to quadrant 2 and so on. So that is one concept that you need to understand. Now, let's start with a point in quadrant 1. Now, would you agree that both the x and y coordinates for this point are positive? First quadrant, x is positive because it's to the right of the origin. Y is positive because it's above the origin. So both A and B are positive. On the other hand, when you come to the second quadrant, the x coordinate is negative A, whereas the y coordinate is still positive. And in the third quadrant, you tell me. Sorry about that. In the third quadrant, x coordinate, would you agree, is negative? What about the y coordinate? Well, that's below the origin, so even the y coordinate is negative. So both x and y coordinates are negative in the third quadrant. And in the fourth quadrant, x is positive, y coordinate is negative. So that's what happens, right? Okay, what's the big deal about this? The big deal about this is going to affect our trig ratios. Okay, this influences the trig ratios. For instance, if theta is in quadrant 2, that is between 90 and theta is between 90 and 180 degrees, then sine theta is y over r, y is b, r is square root of a square plus b square. So we have b over square root of a square plus b square. Now b is positive, square root of a square plus b square is positive, so this whole thing is positive. Whereas when we get to cosine theta, we have x over r, x happens to be negative a, over r is of course positive. So cosine theta is actually negative. And tangent theta is y over x, which is b over negative a. And b is positive, whereas negative a is negative. So tangent theta would be negative. Cosecant theta, on the other hand, would be positive because it's the reciprocal of sine theta. Sine theta is positive, so its reciprocal must be positive. 1 over some positive number is still a positive number. And secant theta, reciprocal of this, would be negative. So secant is negative. Cotangent is also negative. So what have we found? We found that so far as second quadrant is concerned, sine and cosecant are positive and all the other trig ratios are negative. Cool? That's the point I'm making. Sine theta and its reciprocal cosecant theta are positive in quadrant 2 and all the other ratios are negative. And by a similar analysis, we can find which trig functions are positive in which quadrants. Okay. And it turns out in the first quadrant, all the functions are positive. In second, sine and cosecant. In the third, tangent and cotangent. Fourth, cosine and its reciprocal secant. So if we remember this, all is this one. If you remember sine, tan, cosine, automatically the other ones we can know based on the reciprocal relationship. So what people have done is they came up with this mnemonic. All students take calculus. That's a lie. All students do not take calculus. Come on, only smart people like us, we take calculus, right? Okay, and how are we supposed to use this? All means in first quadrant, the first word is all, which is for first quadrant. So all the trig functions are positive in the first quadrant. The second word is students, starts with an S, so that means sine is positive. Automatically its reciprocal cosecant is also positive in the second quadrant. This one starts with a T, which is for tangent in the third quadrant. Tangent and its reciprocal cotangent. C is for cosine and its reciprocal secant in the fourth quadrant. So all students take calculus. Back in India, we remember this as all silver tea cups because people drank tea quite a bit. Like in the British guys, we drink tea quite a bit. All students take calculus or all silver teacups. Either way, you can remember this one. And one more concept. Reference angle. Very important concept. Okay? Let theta be an angle in standard position. That means like you got a XY coordinate system and the one end of the line segment is at the origin and the other one is wherever. So that that line segment makes an angle of theta with respect to the positive x-axis. Now, when theta is such an angle, the reference angle theta bar, we put a bar there, right? So theta bar associated with this theta is the acute angle formed by the terminal side of theta and the x-axis. Is that what Americans say, clear as mud? The reference angle theta bar associated with theta is the acute angle formed by the terminal side of theta and the x-axis. Well, it looks complicated, but it's not. Okay, let me explain. Now, which quadrant is theta right now in? It's in the first quadrant. Cool. What is the angle of this terminal side? So basically this is the terminal side. Initial side was along the positive x-axis. The terminal side, that means where this ray is what is that? What is the angle of the terminal side with respect to the x-axis? Acute angle. Acute angle? What in the world is acute angle? Acute angle is any angle that is less than 90 degrees. That means let me be precise. An angle between 0 and 90 degrees is called an acute angle. So the question is, what is the angle of this ray? What is the acute angle of this ray with respect to the x-axis? Well, theta is already an acute angle, right? It is definitely between 0 and 90 degrees as long as it falls in the first quadrant. So theta is equal to theta bar. Theta bar is equal to theta in this case. Duh. Okay, what else? Now, when we get to this thing, the angle theta lying in the second quadrant, things are going to be different. Is theta an acute angle with respect to this x-axis? Theta? No, it's greater than 90 degrees. So theta is an obtuse angle. It is greater than 90. So now we should say, I want to find the angle of this one with respect to the x-axis, which is acute. Okay, how about this? Is that an acute angle? Is that less than 90 degrees? Yes, it is. Is this an angle of the terminal side with respect to the x-axis? Yes, it is. It happens to be with respect to the negative x-axis, but we don't care. The definition says it's as long as you pick x-axis, we are good. So this is the theta bar, the reference angle for this theta. And as we can see, this is 180 degrees line, this part. So to get theta bar, from theta, you come all the way to 180 and go back by theta. We go back, or maybe I shouldn't explain that way. 180 minus this theta would give us this angle. That's a simpler explanation. From here all the way to here is 180 degrees. And if we subtract this, we are left with this, which is theta bar is 180 degrees minus theta. So for an angle that lies in the second quadrant, how do you find the reference angle? Subtract that angle theta from 180 degrees, you got the reference angle. Or theta bar is pi minus theta radian. If you happen to have theta in radian and you want the final answer also to be in radian, do a subtraction from pi, not 180 degrees. Pi radian, not 180 degrees. Cool? Third quadrant. Well, third quadrant, theta is definitely not acute if you start with respect to positive x-axis. So we say, okay, I'm going to measure it with respect to this, so that this angle is acute. Cool? So that angle is acute. All the way from here is 180 plus something. If I subtract 180 from it, I get this theta bar. So theta bar is theta minus 180. In other words, if you have an angle in a third quadrant that is between 180 and 270, you find the reference angle by saying theta bar is theta minus 180. Subtract 180 from it, you are in business. Cool? Finally, if something is in the fourth quadrant, that is definitely obtuse, not acute. So this time we will measure this angle, which is acute, with respect to the x-axis, positive x-axis. And how do we do that? If we came full circle, we get 360. So 360 minus theta is what we do to get theta bar when theta lies in the fourth quadrant. That's the idea. We definitely need this in order to evaluate trig functions. And I'll show you precisely how. Okay, problem. Find the reference angles of 135, 243, 32 pi thirds radian, 7 pi 4 radian, and all that. Cool. Simple problems. 135, what quadrant? Is it between 0 and 90 and 90, 180, 180, 270, 270, 360? To me, 135 seems to be between 90 and 180. So that means second quadrant, right? And how do we find reference angle theta bar for second quadrant angle? Subtract theta from 180. So 180 minus theta, that is 180 minus 135 is 45 degrees. Cool. 240 between what? 180 and 270? Yep, that's third quadrant. And third quadrant, what do we do? Theta minus 180. And so we get 60. 330 made a boo-boo. Oh, come on, Sammy. Is in quadrant IV. Oh boy. Is it quadrant 4? We have reference angle theta bar equals, what do we do? 360 minus theta. So that's going to be 30 degrees. And 2 pi thirds. I typically change things to degrees. I can see things much better with degrees. 2 pi thirds. Wait, where is it? That's between pi halves. Can you tell readily that it's between pi half and pi? If you can, then more power to you. That's a little. Pi halves, you have to get a common denominator. Pi halves has a denominator of 2. 2 pi thirds is a denominator of 3. So the common denominator is 6. And so that means pi half is the same as 3 pi over 6. And this is 4 pi over 6. 3 pi over 6. This is 4 pi over 6. So this is that's the way you have to. I hate that. Instead, just convert to degrees. Especially, how come 2 pi third radian is 120 degrees? This is how I do it. Pi thirds is 60 degrees. How do I know that? Multiply pi thirds by 180. Yeah, multiply 2 pi third. Sorry, take it back. Pi third radian is 60 degrees. Okay, how we need to multiply pi thirds by 180 over pi. Pi's cancel. We end up with 180 over 3. 180 over 3 is 60. So pi thirds is 60. So what is 2 times pi thirds? 2 times 60, which is 120. What is 4 pi thirds? 4 times 60, 240. What is 5 pi thirds? 5 times 60, 300. Boom, done. Pi fourths is 45 degrees. What is 3 pi fourths? 3 times 45 degrees. What is 5 pi fourths? 5 times 45 degrees. What is 7 pi fourths? 7 times 45 degrees. So simple. Okay. Pi half is 90, pi thirds is 60, pi fourths is 45, pi sixths is 30. That is so simple to me. So, okay, so 2 pi thirds is 120 degrees. 120 degrees, I can clearly see that being 90, between 90 and 180, that is quadrant 2. And quadrant 2 means subtract from 180. So reference angle theta is 180 minus theta, that is 60 degrees, but 60 degrees, if you want to get everything back into radian, 60 degrees is pi third radian. There we go. Cool. 7 pi fourths, same idea like I said. Pi fourths is 45 degrees, 45 times 7 is 315, and so 315 subtract from 360. Is 45 degrees is pi fourth radian. Cool? Now, why did we learn all this stupid nonsense? We did because it helps us figure out trig functions of just about any angle. Okay? I should have said just about. Find the reference angle. What's this? There are three steps. Find the reference angle theta bar of angle theta. So somebody says, hey, tell me what is sine of 120 degrees? You will say, oh, theta is 120. But 120 is in second quadrant. Hang on. That's not an acute angle. So let me find the reference angle. 120, the reference angle is 180 minus 120, which is 60. Okay, so that's the idea. So find the reference angle theta bar and then find the SIGN sign, meaning positive or negative. Find the sign of the trig function of theta based on the SOHCAHTOA mnemonic. So what do I mean by that? If we are being asked to find sine theta, theta is say 120 degrees, sine of 120 degrees, ask yourself, is sine of 120, sine of an angle in the second quadrant, is it positive or negative? Oh, all students take calculus. Based on that, did I say SOHCAHTOA mnemonic? I'm such an idiot. Come on, it's not based on the SOHCAHTOA mnemonic. Based on the all students take calculus. Based on that mnemonic. Okay. Based on the all students take calculus mnemonic, figure out the sign. The same thing if we were looking at cosine of 120 degrees. Oh, cosine is negative in the second quadrant. So that's the sign. You need to figure out what the sign, SIGN sign is, positive or negative. And then find the trig function of theta bar. Of the reference angle, you find the trig function. Even though our original idea is to find the trig function of a theta, we find trig function of the theta bar, which is an acute angle, and we already have that memorized. I'll show you quite a few examples, okay? So if you like, I don't know what you're talking about, man. Don't worry about it. And attach the sign we found in second step. Okay, let me do this now. Find the trig ratios. Sine of 135. We got 6 problems. Sine of 135, cosine of 240, all of this. So let's get, without much further ado, let's get busy. Sine of 135. Find the reference angle theta bar, right? For 135, 180 minus 135. Theta is 135, theta bar is 180 minus theta is 45 degrees. Cool. Find the sine of the trig function of theta, sine of a second quadrant angle. Since theta is 135 is in Q2, sine is, what is sine in second quadrant? All students take calculus, positive. Cool. Finally, step 3. Sine of 135 is therefore the same as sine of the reference angle, which is 45 here, is guaranteed to be the same as sine of 45. And the only thing is it positive sine 45 or negative sine 45? What did we say in step 2? Oh, that is positive. What is positive? Sine of an angle 135, which we are looking for. At 135 is in second quadrant, sine of a second quadrant angle is positive, so we put a plus sign here. So it's not negative, it's plus positive sine 45. Sine 45, what is sine 45? My hope is you have that table memorized. Sine 45, square root of 2 over 2. So square root of 2 over 2. That's the answer. Done. Cool. Let's pick cosine of 240. Step 1. Since theta is 240, what should you do? What quadrant is that? 240. Between 180 and 270, third quadrant. Third quadrant, what do? 240 minus 180. So that's theta bar is 60 degrees. Step 2. What quadrant? Third quadrant. Cosine in third quadrant. All students take tangent. Tangent is and its reciprocal are the ones that are positive. So when we are looking at cosine, that is negative in the third quadrant. So step 2 is in Q3, cosine is negative. Step 3. Cosine of 240 is therefore same as cosine of 60, the reference angle. The only thing is you must take a negative sign based on step 2. And cosine 60 is 1/2, so negative 1/2. Done. Is this making sense, folks? Cool. C. Tangent of 330 degrees. 330 is in quadrant 4. So 360 minus 330 is how we find the reference angle, which turns out to be 30 degrees. Step 2. Fourth quadrant, tangent is negative. All students take calculus. Calculus. C is cosine. Cosine is positive and it's reciprocal. So tangent must be negative. Tangent is negative. Step 3. Tangent of 330 is tangent of 30, the reference angle. The only thing is take a negative sign based on step 2. And that turns out to be tangent of 30. I don't know, sine 30 is 1/2, cosine 30 is square root of 3/2, 1/2 over square root of 3/2 is 1 over square root of 3, negative 1 over square root of 3, negative square root of 3/3. Cool. Tangent of 2 pi thirds. I don't know what tangent of 2 pi thirds is. 2 pi thirds is 60. 2 times pi thirds is 2 times 60 is 120. Oh, tangent of 120 basically. So that is 60 degrees. Since theta is 120 is in quadrant 2, tangent is students, sine, and so tangent must be negative. Tangent of 2 pi thirds is tangent of 60, the reference angle 60. The only thing is negative. Negative square root of 3. Cool. Sine 60 is square root of 3/2. Cosine 60 is 1/2. So square root of 3/2 over 1/2 is square root of 3. That's what I did. Secant of 7 pi fourths. Pi fourths is 45. 7 times 45 is 315. That's in the fourth quadrant. So subtract from 360 your theta and you got the reference angle 45 degrees. Since theta is 315 is in quadrant 4. Secant. Secant is the reciprocal of cosine. Calculus. Fourth quadrant is calculus. Cosine and its reciprocal secant. They're both positive. So the secant is positive here. Cool. Secant of 45 degrees. Secant of 45 degrees? I don't know. But I know cosine of 45 is square root of 2/2. Or 1 over square root of 2. So the reciprocal is square root of 2 and positive square root of 2. Cool. That's the idea. Oh, cosecant of negative 11 pi over 6. Negative? Okay, what do we do? I don't know. Since this is negative 11 pi over 6, we'll make it into degrees, negative 330 degrees. If we have negative 330 and we add 360, what do we get? 30? Isn't that nice? Negative 330. Picture it going clockwise into the first quadrant. So basically it's in the first quadrant. However, we add 360, right? Because it went in the negative direction. So 30 degrees is the, or simply ask, with respect to the x-axis, what is the acute angle? 30 degrees. And first quadrant, cosecant is everything is positive in the first quadrant, so cosecant is positive. So cosecant of negative 11 pi over 6 is cosecant of 30 degrees, and cosecant of 30 degrees, I have no idea, but I have an idea of what sine of 30 is, which is 1/2. So cosecant must be the reciprocal of that, which is 2. All right, so that's about that. Ooh, yeah, these are nice. Find the quadrant in which theta lies from the information given. Tangent theta is less than 0, sine theta is less than 0. Where is theta? Does the question even make sense? Find the quadrant in which theta lies from the information given. Tangent theta is less than 0, sine theta is less than 0. That's a fancy way of saying tangent is negative and sine is negative. So the way I deal with these things is, the moment I see, oh, tangent is negative, where does that happen? Well, not first quadrant. First quadrant, everything is positive. Third quadrant is where tangent is positive. So not first, not third. That leaves us with second and fourth. So tangent is negative in second and fourth quadrants. But then sine is positive in the first and second. So that means sine is negative in the third and fourth. What is that? Sine is negative in third and fourth. Tangent is negative in second and fourth. Second and fourth, third and fourth. What's common? Fourth. That's the way I do it. So tangent theta, since tangent theta is less than 0, is negative, theta could be in quadrants 2 or 4. Since sine theta is less than 0, theta could be in quadrants 3 or 4. So which one is common? Second, there is no second here. Fourth, fourth. So theta is in the intersection of the two sets, that is, theta is in Q4. Cosecant theta is greater than 0, cosine theta is less than 0. Cosecant is greater than 0 and cosine is less than 0. Cosecant, that means sine is also greater than 0. Sine is positive, but cosine is negative. Cosecant greater than, that means first or second, and cosine is negative, that means second or third, right? First and fourth is where cosine is positive, so second or third is where it's negative. Intersection of the two is quadrant 2. Cool. Now find the values of the remaining trigonometric functions given tangent theta is equal to 4/3, theta is in Q3. What? Find the values, the remaining trigonometric functions given tangent theta is 4/3 and theta is in the third quadrant. Very, 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 very important problems. You got to know how to do them. Cool. Let's do this. Solution. Since theta is in Q3, both x and y are negative. That's the first realization you need to make. They have put the theta in the third quadrant where x and y are both negative, but they are saying tangent theta is 4/3. What do they mean by that? So here what we do is further recall that tangent theta is y over x, right? So thus y, you cannot say tangent theta is 4, maybe pay attention to this please. Tangent theta is 4/3, but tangent theta is y over x. So should we say Aha, so that means 4/3 equals y over x, and so y is 4 and x is 3. Is that what we should say? Not quite, because we have already established that both x and y must be negative. So, truly speaking, we need to interpret this as the y over x being equal to 4 over 3 as y is actually negative 4, x is actually negative 3. It just so happens that the negative signs cancelled, giving us with a 4/3. Whoa. Right? Look at that, how clever we need to be. But I hope it made sense. Okay, let me repeat just once more for the sake of those who may not have got it. Tangent theta, we are given that it is 4/3. We know tangent theta is y over x. So basically, can we say y over x is 4 over 3? And so y is 4 and x is equal to 3? No. That is because this theta is in the third quadrant, and so x and y both must be negative. 4 is not negative, 3 is not negative, so you cannot say y equals positive 4, x equals positive 3. However, we could say y is negative 4, x is negative 3. That's okay. And in fact, that's what we must say. Once we know that, can we figure out R? Pythagoras theorem. Negative 4 quantity square plus square root of negative 3 square. That's how you find that, and that turns out to be 5. Once we know this, we need to draw this kind of a picture. You draw the coordinate system and clearly identify, draw the ray that is in the third quadrant, and draw a right triangle like this. Okay, and the x value is negative 3, so that means this horizontal leg is negative 3 and the vertical leg is negative 4. That's the y, and R is 5. On the triangle itself, be absolutely sure to label every one of the sides, how much, what its value is, and make sure you have the correct positive and negative stuff. So negative 3 for x, negative 4 for y, but R is positive 5. Okay, at least in this context, we will always have R to be a positive quantity. Okay, at least in this context. Okay, once we get that, we are in business. Sine theta. Sine theta is y over R, negative 4 over 5. Cosine theta, x over R, negative 3 over 5. Right? Cotangent theta is a reciprocal of tangent, so 3 over 4. Like that. Sine theta, y over R, negative 4 over 5. Cosine theta, negative 3 over 5. Cosecant, negative 5/4. Secant theta, negative 5/3. Cotangent, 3/4. Ta-da! Effortlessly you can solve the problem. But you got to do some work. Cool. Let's see. Problem. Find the values of the remaining trigonometric functions given. Cosine theta is negative 2/7 and tangent theta is less than 0. Whoa. So they didn't even tell us which quadrant theta is. But not to worry. Cosine theta apparently is negative 2/7. So that means cosine is negative, tangent is negative. Where does that happen? Cosine is negative, meaning second or third. Tangent is negative, meaning second or fourth. So the intersection is second. So from the two conditions, theta is in quadrant 2, where x is negative and y is positive. And R is always positive. So the way we interpret this is R is 7. We draw an angle in, we draw this thing in the second quadrant because this is in second quadrant. So our ray is in the second quadrant. R with an R value of 7 and X value of -2. And so apply Pythagoras theorem. 7 square minus y is square root of 7 square minus -2, the quantity square, that's square root of 45. Write that here. And sine theta is y over r, that is square root of 45 over 7. And tangent, that is y over x, like that. Okay, all the stuff I hope is all pretty straightforward. Cool. So that pretty much concludes this section, folks. Absolutely be sure to work on tons of problems so that this actually becomes second nature to you. Okay? Alrighty.